Hey, welcome back. So this is the Test 2 review for Math 1620. There's a guide for studying in Webassign the problem types for 7.1. I'm thinking like 5 to 13. 7.2, problems like 1 to 5, and then 8 to 10. 7.3, 1 to 7, and then 7.4, problems like 1 to 8. As I was going through the sort of doing my review, well, first off, these things for shell and disk and washer methods, I'm only going to do x-axis or y-axis rotations. I'm not going to bother with shifted axes. But what I noticed in going through and doing my review is that the questions in Webassign are often quite obnoxious. So, for like example, here's with regards to the numbers involved in some of the graphs. So number 2 in Webassign was y prime equals x squared plus 2x plus 5, and then y sub 2 would be 2x plus 30. Right off the bat, this thing has a y-intercept at 30, so if you were to try to graph this thing, you'd have like 30 tick marks on there. I would, just do one of these jobs and put the number 30 here, and it's a line with positive slope, so it's going to be going like this. So that's the graph of that guy. The graph of the other guy, and what we're doing in 7.1, if you've forgotten, we're finding the area between curves. Okay. The graph of the other guy, to get the vertex, you can use the formula negative b over 2a. So for the x coordinate, negative 2 all over 2 times 1 is negative 1. The y coordinate, then you just plug negative 1 into the equation, so you get 1 minus 2 plus 5, which of course is 4. And find where that is. It's negative 1, 1, 2, 3, 4, about right here. Its leading coefficient is positive, so it's going up like this, and you kind of have a picture of it. For the problems on my test, I tried to just take ones like from the book here. That way the graphs weren't too obnoxious, and they didn't really, like in this case, go to on the y-axis 30. You can see most of the graphs in the book as I kind of scroll through here. They rarely go beyond 10. So anyways, what I'm trying to say is I'm more likely to pick questions for this test from the book just because I think they're actually easier. In that regards, you have a graphing calculator, but I think you should be able to graph these even without the calculator. You should be able to graph a parabola. So things of the form y equals ax squared plus bx plus c. In that case, you have this version if a is greater than 0, and you have this version if the leading coefficient is less than 0. And then the vertex for those guys is always negative b over 2a, comma f of negative b over 2a. So you should be able to graph parabolas. You should be able to graph equations of lines, like y equals mx plus b. You should be able to kind of graph radicals, like square root of x. Radicals just always look like this, unless they're shifted around in the plane. You should be able to kind of handle rationals. So these are all things they've taught you how to do in pre-calculus. And I expect you to be able to kind of get an idea of the picture. Worst comes to worst, you'll have to graph them with your calculator, but I expect you to be able to graph the simple ones by hand. Okay, so the deal with these problems is they want you to find the area of the enclosed region, and that's just an integral of the top curve minus the bottom curve, depending on your orientation. If it's with respect to x, looking at my Riemann man, the top curve is going to be the straight line 2x plus 30, and then the bottom curve is the x squared plus 2x plus 5, and then it's all of this dx. I need to find the limits of my integral, so you can find that by setting the two equations equal to each other. and then solving, so you get x squared minus 25 is 0, so x plus 5, x minus 5 is 0, and then you get x is negative 5, and then 5. Okay, so you're going from negative 5 to 5, and then again, you're going to get some obnoxious numbers because this is a Webassign problem. But for most of them, I think on the test, like I said, I took the ones from the book. They're a little easier to manage, in my opinion. Anyways, what do we have here? We want to distribute, so you have to simplify first. Don't integrate first. Simplify first. So minus x squared minus 2x minus 5 dx. Then combine like terms. So you'd end up with 25 minus x squared. And then you can integrate, so you get 25x minus x cubed over 3 from negative 5 to 5. And there you're starting to see it, right? This is going to be annoying. 25 times 5 is 125. You might need a calculator, right? 5 cubed is 125 over 3 minus, plugging in a negative, so now I get negative 125, and then plus 125 over 3. That will leave me with 125 plus 125 is 250 minus 250 all over 3, and then find a common denominator, so you get 3 250s minus 1 250s over 3, which is 2 250s over 3, which is 500 over 3 at the end of the day. So, depending on how good you are at arithmetic, something like that can be kind of a nightmare. You're going to see in some of the later problems that I took from Webassign, yeah, they're annoying. But hopefully, I'll pick the ones from the book that aren't so bad. Speaking of ones from the book, let's look at one that has a different type of orientation, in particular number 24. So we have f of y equals y times 2 minus y, and then g of y equals negative y. Okay. So back here, this is a Webassign problem. Right here is just a problem I took from the book. You can see it on the right. That's the book. Okay. So f of y, if you rewrite this, you're going to get 2y minus y squared. You could get the intercepts if that helps. Excuse me. It'll be 0 equals 2y minus y squared. 0 equals y times 2 minus y. Oh, it was already factored. Oh, I'm an idiot. Okay. So y is 0, and then 2 minus y is 0, so y equals 2. So those are the intercepts. The leading coefficient is negative, so it's a sad face scenario with the parabola. So you have 0, 1, 2. So it's going to be something like this. I'm not sure where the vertex is. You probably don't even need to find the vertex. The graph of y equals g of y equals negative y is just x equals negative y. In other words, it's y equals negative x. And so we have this character here. Whoops. Upside down diagonal. It's the other direction. It's a diagonal going through the origin, and I predict it'll eventually hit right there. It would be a bad. Okay. So I did make a mistake there with the parabola, right? So it's y equals 0 and y equals 2. I'm sorry. So y equals 0, y equals 2, and then it'll look like this. Given the orientation, now our Riemann man is going up the flagpole in this direction. And then negative x, it's the same graph as what I did in the xy plane. And the other orientation, it will go like this. So, right, the top curve in this orientation is the one to the right, okay? It's the parabola. So on your integral, you're going the y times 2 minus y. You might as well just write 2y minus y squared. And then you're subtracting away the bottom curve, or the curve to the left, which is minus negative y, and then dy. I need the intersection places. I know one of them is 0. I just need to find the other one. And you could equate the two equations up here somewhere. So negative y equals 2y minus y squared. So you can plug the y squared on the other side, or move it to the other side, add it to the other side, and then subtract the 2y to the other side, so you get y squared minus 3y. equals 0. So you get y times y minus 3 is 0. So you get y equals 0, which is one of our limits. And then y equals 3 is the other limit there. Okay. Okay. So once you have that, then you can go ahead and well, simplify first, right? So 2y minus y squared plus y. Then you combine like terms. So I have 2y plus y is 3y's minus y squared dy. And then you can integrate that thing, so you get 3y squared all over 2 minus y cubed all over 3. And we're going from 0 to 3 on the y-axis. Plugging in 3, I get 3 times 3 basically is 27 halves minus 27 thirds, and then minus a big 0. Plug 0 into the antiderivative, you get 0. So you're going to get, finding a common denominator, you get 3 27ths minus 2 27ths all over 6. And then 3 27ths minus 2 27ths is just 1 27ths all over 6. Then you can divide top and bottom by 3, and you get 9 halves for your answer. Okay, so that's just finding the area between these two curves. So you should be able to handle sort of the normal orientation, and then if I ask the sideways kind of orientation with horizontal rectangles, I think that's the way that they kind of described it in the book, if you remember, horizontal rectangles like that. Okay, so anyways, let's move on to 7.2 and see what's in there. So 7.2 was the disk and the shell method. So let me move in my book a little bit to 7.2 and the exercises. So take a look here. The formula for the disk method, and you know, it could have been in terms of y or x, depending on where your little rectangles are. The base of the rectangle is always on the axis of the variable you're integrating with respect to. Okay. So anyways, the one formula is pi r squared, you know, dx or dy, depending on which one you want to use. That was the disk. The washer is pi big R squared minus little r squared, and then dx or dy, depending on your variable of integration. Okay. Okay, so it's those two formulas you really need to have for this section. Let's look at maybe one from the Webassign, just so we can kind of see again how annoying these can be. And hopefully you won't be upset if I don't include the Webassign problems. Y equals 5x squared, y equals 0, x equals 3. And they want you to do first on a y-axis rotation. So again, I'm only going to do y-axis or x-axis rotations. Let's get a picture. So 5x squared is basically just a parabola, kind of like this. At 1, it's at 5. At 2, it's going to start going up really fast. 2, 3. At 3, this point right here is going to be at 45. Okay. So again, it's this ridiculous number generation problem that we're dealing with from the software that's giving you these huge numbers. I'm doing a y-axis rotation. In this case, the rectangle would look, sorry, that would be for a shell. Well, I haven't even marked off the region yet, have I? So y equals 0 is the x-axis. X equals 3 is this vertical line here. And so the enclosed region we're dealing with is this region. And then when I rotate it, it's going to have kind of a hole in it. You could reach your hand into it. In other words, it's going to be a washer problem. Okay, so I'm going to need a big R, and the base of this rectangle will be on the y-axis. So it's going to be a big R of y and then a little r of y. Okay, so the big R of y is the distance all the way to that straight line there. Okay, that x equals 3. So big R of y is just 3, and then little r of y will be variable, and it's basically the distance to the bottom of that rectangle. Okay, so that would be given by this formula, but you need to find it in terms of y. So I need to take that guy and solve for x. I'll have x squared equals y over 5, and then taking square root on both sides, plus or minus square root of y over 5. I only need the positive arm, so little r of y is going to be the square root of y over 5. Okay. Then I go to my formula, so it's pi integral. My Riemann man, whoops, he's going up the flagpole this time. So he's starting here at 0, and then he's going all the way to 45. So 0 to 45. R squared is 9. Little r of y squared is just going to be y over 5 then. dy. And then you see, okay, there's going to be big numbers because the computer is an idiot. So I end up integrating here. So get rid of the integral symbol. 9y minus y squared over 10, and we're evaluating from 0 to 45. So I'm going to get pi times 405, and then I just went to the decimal form. It's really 2025 over 10. But when I put that in my calculator, I just put it in my calculator. I was like, that's enough. 202.5 pi is the exact answer. So, yeah. Okay. Let's look at one from the book then. That may be a little bit easier to manage, like number 15. This is going to be another washer, but anyways, y equals x squared, and then y equals 4x minus x squared. So first got to graph the thing. This guy on the right, this function on the right, I can find its x-intercepts by factoring a little bit. So 0 equals x times 4 minus x. So x is 0, and then x is 4. The vertex is going to be at h equals negative b, which is 4, all over 2 times a, which is negative 1. So that would be 2. The y-coordinate then would be 8 minus 4, which is 4. Okay. So I kind of have a picture. I want to see where they intersect, so I'm going to set them equal to each other. Minus x squared. So it's going to be 2x squared minus 4x equals 0. Factor out 2x, and you get x minus 2 is 0. So x equals 0, and then x equals 2. Putting all that together in my picture, what do we get? So 1, 2, 3, 4. 1, 2, 1, 2, 3, 4 was the vertex. That's also going to be the intersection point for these two curves. Okay. So the parabola x squared is going to go like this. And this will be the enclosed region. And then we're going to rotate about the x-axis this time. Okay, so I'm going around here like that. The little rectangles are going to be like right here. The rectangles are perpendicular to the axis of rotation for the washer and the disk method. Again, this is going to be a washer because we have a hole in it, basically. So they're going to be in terms of r of x because the base of the rectangle is on the x-axis, sort of. So the big distance, the big r of x is the distance to the top of the rectangle. Little r of x is the distance to the bottom of the rectangle. So the distance to the top of the rectangle is going to be this 4x minus x squared. The distance to the bottom of the rectangle is just going to be x squared. So my integral is going to be going from, and here's my Riemann man, he's going to be running from 0 to 2. We need a pi in front, and then we have big R of x, 4x minus x squared squared minus x squared squared, okay, dx. It's a bit annoying. You got to do some foiling there. So we have pi integral 16x squared minus 8x cubed plus x to the 4th minus x to the 4th. So you get a little bit of nice cancellation. So I get 16x squared minus x cubed, 8x cubed. And then I can integrate. So I'm getting 16x cubed over 3 minus 8x to the 4th over 4, which will be 2x to the 4th from 0 to 2. And then We just plug in our numbers, right? So plugging in 2 into the antiderivative, I get 8 times 16, whatever the heck that is. 8, you know, like 128, I hope, all over 3 minus 32. I want a common denominator, so 32 times 3 is going to be 96 over 3, I hope, and then minus 0. 128 minus 96, 2, this is going to be a 3, 32 over 3, 32 over 3 pi. And then hope you got it right. Yeah, okay, so that's 7.2. 7.3 then, we're getting into the shell method, and let's take a look at some of those problems. Again, I'm only going to be worrying about x-axis and y-axis rotations. The formula for this shell is a little bit different, right? It's 2 pi integral. We'll have some radius function in terms of x or y, and then you'll have some height function in terms of x and y, and then, you know, integrated with regards to whatever variable. So you have to identify rho and h. Let's look at first, like, an easy one. Well, maybe look at a harder one, number 4. So I probably wouldn't put one like number 4 on the test, but it is in the Webassign. 1 all over the square root of 2 pi e to the negative x squared all over 3. Okay, so if you're not familiar with this function, you should be. It's the normal distribution function, so a bell-shaped curve basically. So if I were to graph it, it's going to look like this. Okay, and you see it in probability and places like that. Let's see what else they have. So they want not only the area they're after is the area enclosed by this curve, the curve y equals 0, which is the x-axis, the curve x equals 0, which is the y-axis, and then the curve x equals 1. So let's say x equals 1 is probably about right there. This is the region I'm dealing with, and I want to rotate it about the y-axis. Okay, so all that information will be given to you. I probably won't give you pictures though, right? But I'll expect to see your picture. If you don't draw me a picture, I'm going to wonder what the heck, how the heck did you get your answer? So anyways, for this, the shells are parallel to the axis of rotation. So your shell, the cross section should look like that red rectangle I just did. The base of that red rectangle is on the x-axis, so everything's going to be in terms of x. There's your Riemann man who's going to run across and get those things. So our radius function and our height function are the things we're after. The radius function, if you're rotating around the y-axis, will always be x. If you're rotating around the x-axis, it'll always be y. The height function then is just the height of that rectangle, which in this case is the 1 all over square root 2 pi e to the negative x squared all over 3. Okay, so let's dump all this into our integral then. So I have 2 pi integral from 0 to 1 of x times 1 all over the square root of 2 pi e to the negative x squared over 3 dx. Factor out the 1 over square root 2 pi. 2 pi over square root 2 pi is just square root 2 pi. You can subtract exponents if you want. And then we have the integral of x e to the negative x squared over 3 dx. You're going to have to do a u sub. U is negative x squared over 3. Du is negative 2x over 3 dx. So dx will be negative 3 all over 2x du. Okay. So rewriting square root 2 pi integral x e to the u times negative 3 all over 2x du. The x's nicely cancel. You can factor out the negative 3 halves, so you get negative 3 square root 2 pi all over 2 times the integral of e to the u du. And then that will be negative 3 square root 2 pi all over 2 times e to the u. Back subbing, you get e to the negative x squared over 3. And then I have to evaluate from 0 to 1. Plugging in 1, you get negative 3 square root 2 pi all over 2. Let's factor that out of the antiderivative. So plugging in 1, you get e to the negative 1/3. and then minus plugging in 0, you just get e to the 0, which is just 1. So let me just write 1 there. Okay. You can leave your answer like that. There's no need to get an approximation for me. I'm not that fancy. Okay, so there's one that was a y-axis rotation. Let's look at an x-axis rotation. So something like number 14. No, let's not do 14. 15 is one of those hard ones. So let's look at number 15, where you have to split it into 2 parts. And I will tell you which method I want you to use. So it's either going to be disk or washer, or it's going to be shell. And I'll tell you, and it's in order of the book. So the first 2 questions, or the first 4 questions, are going to be 7.1 problems. Those are really the most important. And then the next 2 questions will be 7.2 problems. So you're looking at disk and washer. And then the next 2 questions will be 7.3 problems. So you're looking at shells. And then the last 2 questions will be arc length problems. Okay, so anyways, number 15, let's take a look. It's probably quite annoying. 1 over x, and then the other parts of the, x equals 1, x equals 2, and y equals 0 would enclose the following regions. So 1 to 2, if you plug in 1, you get 1. So if this is 1 and this is 1, I know it's out of whack, but if you plug in 1, you get 1. If you plug in 2, you get 1/2. So the curve is going to be like that in this region. And then x equals 1 is there, x equals 2 is here, y equals 0 is the x-axis. So this is the region I'm worried about, and I want to rotate it about the x-axis. Okay, again, shells are parallel, but you have an issue with one rectangle being constant in the first region, and then the next rectangle is variable in the second region. So you're going to have 2 integrals to stomach, right? So region 1, the bottom region, I'll say the radius function, and think about the orientation with your Riemann man. He's going in this direction. So from 0 to 1/2, the radius function, because we're in terms of y, is just going to be y. The height function then for that rectangle is always going to be 2 minus 1, which is 1. Okay? When we get in the region 2, that height function becomes variable, so we'll have to rewrite that as something else. But the radius function will still be y. Then the height function is going to be a difference, right? It's going to be the difference between this distance to the top of the rectangle and then the distance to the bottom of the rectangle, right there. So it'd be that difference. Okay, so the distance to the top of the rectangle is given by this formula, kind of. We need it in terms of y, though. Right? So I solve for x, and x is going to just be 1 over y. So the distance to the top of the rectangle is 1 over y, but then you have to subtract away the distance to the bottom, which is a constant, 1. Okay, so you got 2 integrals. 2 pi always goes in front. Did I put a 2 pi up there? Then we have 1 times y dy, and that's the integral from 0 to 1/2. And then plus 2 pi times the integral from 1/2 to 1 of y times 1 over y minus 1 dy. Okay, so the first integral, 2 pi y squared over 2, so just pi y squared from 0 to 1/2. And then plus 2 pi, if you distribute that y, you're going to get 1 minus y dy. So I need to worry about that, integrate that. Doing some integration here, factoring out the pi from the antiderivative, you're going to get 1/4 minus 0, so just 1/4. The second integral then is going to be y minus y squared over 2 from 1/2 to 1. So I get pi over 4 plus 2 pi times 1 minus 1/2, and then minus 1/2 minus 1/8. So that's going to be pi over 4 plus 2 pi times 1 minus 1/2 minus 1/2. That's 1 minus 1, which is 0. And then you'll just get 1/8 out of that. So that will be pi over 4 plus pi over 4, which is apparently pi over 2. And then you hope that's the correct answer, and you move on with life. Okay. All right, let's then move on to 7.4, where we finally have arc length. So the formula you need to memorize there is the arc length formula. Again, it can be in terms of x or y. Usually, though, it's x. I think both the ones I put on the test were in terms of x. So let me just write it that way. F prime of x squared dx. And the formula kind of comes from the distance formula. So if you kind of remember that, you kind of have at least the square root part of it. You know, it's got to have a square root in there somewhere. Anyways, let's take a look at some of the problems. And I did take these from Webassign. I didn't find these to be too obnoxious. But let's take a look here. So y equals, this is problem 2 in Webassign. Everything else I think above, what did I take most of them from the book, right? So 15 was from the book. This one was from Webassign. And this one was from the book. This one was from Webassign, because it was that had that annoying, and then that was the book. Okay. So number 2 is from Webassign. Y equals 2/3 x squared plus 1 to the 3/2, and I'm going to integrate from 0 to 3. You don't need to draw this. It just is what it is. I am going to need the derivative, so I'll get that. Y prime is 2/3. Bring down the exponent, that's the power rule, and then times x squared plus 1 to now the 1/2, and then times 2x because of the chain rule. All right. Okay, let's rewrite it a bit. So I got 2x, basically 2x, and then times the square root of x squared plus 1. So rewriting the 1/2 power as a square root, x squared plus 1, like that. Okay, then I'm going to dump it into my integral for arc length. So it's 0 to 3, the square root of 1 plus the derivative squared, so that's going to be 4x times x squared plus 1, 4x squared times x squared plus 1 dx. And you should be able to somehow get rid of the square root, okay? Through factoring or in the trig problems using trig identities. Let's rewrite this then. 1 plus 4x to the 4th plus 4x squared. Let's rearrange 4x to the 4th plus 4x squared plus 1. That's a perfect square trinomial. It's basically like you're going to be able to factor into something times something where both somethings are the same. Okay, so the somethings are going to be 2x, looks like 2x squared plus 1, and then kind of FOIL it out in your head and make sure it works, right? So you get 4x squared, now 4x to the 4th, plus 2x squared plus 2x squared plus 1. Yeah, it works. Okay, great. That will allow you to get rid of the square root. So you'd end up with 2x squared plus 1 dx. And then integrating on that, you get 2x cubed all over 3 plus x. Evaluate from 0 to 3. And then 3 cubed is 27, divided by 3 is 9. 9 times 2 is 18, plus 3 is 21, and of course minus 0, but all right. All right, so there's that. Let's maybe take one from the book. Seems like how I've been going lately. So I don't want to do the same problem, right? Let's try number 10, I guess. All right, maybe let's try number 11. That way I have the answer there and we can make sure I'm right. Okay, so number 11, y equals 3/2 x to the 2/3 from 1 to 8. I need the derivative, so it's going to be 3/2 times 2/3. X to the 2/3 minus 3/3 is minus 1/3. Clean that up so I can put it into my integral. It's going to just be x to the negative 1/3. Okie dokie. So s is equal to the integral from 1 to 8 to the square root of 1 plus x to the negative 2/3 when I square it, dx. I'll rewrite that a little bit. Right now, it's going to be kind of hard to do a u sub or anything. What is this? It's 1 plus 1 all over x to the 2/3. I'm going to find a common denominator and add the numerators over the common denominator. So I'm going to change this 1 into x to the 2/3 over x to the 2/3. Right? And then I can combine them over the common denominator, and I can simplify the denominator. I can move it out of the root, the square root thing. Okay, right now it's in the square root, but the square root of a quotient is the quotient of the square roots. So I can rewrite this as square root of x to the 2/3 plus 1 all over the square root of x to the 2/3 dx. And then, of course, x to the 2/3 to the square root of that is just raising it to the 1/2. If you multiply the exponents, you just get x to the 1/3. Oops. So I can rewrite this as the integral of the square root of x to the 2/3 plus 1 all over x to the 1/3 dx. And then you could do your u sub, believe it or not. Okay. So if you allow u equal x to the 2/3 plus 1, du will be 2/3 x to the negative 1/3, and then dx, and therefore dx will be 3/2 x to the 1/3 du, and you get the 1/3 that's in the denominator to cancel out. So you get the integral of the square root of u over x to the 1/3 times dx, which is now 3/2 x to the 1/3 du. Okay, so nicely, there's a cancellation of the variable, the x parts. You can factor out the 3/2, and then you have the integral of u to the 1/2 du, integrating that. So u to the 1/2 plus 1 is u to the 3/2, divided by 3/2 is multiplied by 2/3. I want myself to evaluate. So I'm getting x to the 2/3 plus 1 to the 3/2, evaluated from, I think it was 1 to 8. The third root of 8 is 2, and then 2 squared is 4, and then 4 plus 1 is 5. So I get 5 to the 3/2, and then minus, plug in 1. 1 to the 2/3 is 1, plus 1 is 2, so you get 2 to the 3/2. And that's a pretty good answer right there. You don't need much more than that. Okay. So that'll about do it for my review. Like I said, you could go back and review the kind of exercises in Webassign. You can also then go to the book like I was doing and pick those similar exercises. So if I picked up book problem number 24, look at 23, look at 22, problems in that region, etc. If I looked at book problem 15, look at 16, 17, 18, 12, 11, stuff like that. Okay, and you should be okay. All right. Thank you for watching as usual, and I'll see you next time.